Hello, everyone, and welcome to the Mythyw podcast. This is a special episode. I have a good friend of mine and one of the most intelligent people that I know. He goes by the handle Brain Mountain, and I've known him for 15, 20 years or so. I have no idea, actually. It's something like that. It's been a while, and he's a great musician. He's one of the most intelligent scientific minds. Whenever I have a question about science, computers, and sometimes life in general, I like to reach out to my friend Brain Mountain. And on this podcast, you've heard my friend Jordan doing comedy. I've done some solo stuff, and I wanted to bring in kind of a, not just learning, but taking a deeper dive into some concepts that are very fascinating to me. And that is why I'd like to introduce to you my friend, the one and only Brain Mountain.
Hello, everybody.
So, before the podcast, we had made some notes at one time, and we'd done this before. We talked, we were going to say, we're going to do this podcast at some point, and it never came to fruition. And one of the great parts of doing a podcast with you is that instead of using my guerrilla style cell phone and bullshit like that, because all my friends that are music engineers are always bitching at me that I have such a shitty setup. So Brain came over and set up the good mics and the mixer and the laptop, and now we're rolling.
And hopefully everything's sounding good.
Oh yeah. So should we banter a little bit and then go into the questions, or what do you think? Where are you at?
Whatever you choose.
Okay, well, maybe we should give some backstory to our friendship. I was running wild at 22 years old or 20 years old, and we would meet up at some local watering holes where they had a lot of rock bands playing in music competitions, and we met originally through music. And I think the second time I saw you was at like a record store.
Turn It Up.
That's right.
In Northampton.
Yeah, Northampton, Mass. Quite a hub, and a great place to make connections. But yeah, I was running wild playing tambourine for a band to get the audience hyped up, and that was a wild time because I couldn't find a band to play drums in. And Brain was an amazing guitarist and vocalist, and at points we would do some open mics at frat houses in different places, some bars and things like that, where Brain would play an awesome set on acoustic with amazing vocals, and people would be crying, and it was beautiful. Oh, I know I was, like, in a good way. And it was like really like poignant, emotional, really true art. And that's why I'd always ask him, hey, do you mind playing guitar, like play a riff while I do some poetry? And I'd do some poetry after. I don't know if you remember those days at all.
Oh, very clearly, yeah. Playing the guitar while you were doing your readings and stuff.
Oh yeah.
Just kind of riffing off it.
Those were the days. If I could only remember them, but...
Well, at least we remember some of it.
Yeah, it's like a highlight reel in my mind.
Little snips here and there.
Yeah.
The parts where we weren't blacked out.
Yeah, we weren't doing some wild things. So, all right, now that you know where we come from, I guess, I know you have some really interesting ideas about how to save Earth and to shut up the politicians and the billionaires. So tell me about the solar turbine.
So the idea is not so much to save Earth itself, because I think Earth will be fine without us. It's more an attempt to save, or at the very least help, humanity continue. And one of the biggest things in the world is energy. We use so much energy, and we've burned so much fossil fuel that we're affecting our climate and everything. And though I think the Earth will heal from that, I don't know that humanity can survive what's to come. So, there's wind and solar and, all kinds of ways that people are coming up with to generate energy. So the idea I came up with was what I call the solar turbine. And it's called that because pretty much everything you use to generate electricity uses some kind of spinning motion, a turbine, whether it be wind spinning, a propeller, or hydro, making a dam and sending water through it and spinning a thing.
Right.
So the idea is, and it's a pretty revolutionary idea, and it really wouldn't have been possible until recent things, that kind of like
Scientific developments.
right, that kind of just are very new and happen to coincide with this idea. So what you need to do is convert sunlight into a laser beam, and to do that without it being so hot is you need to filter out the infrared or the heat light, which very recently there are lenses that can do that. So you can condense it down into a laser, and there are things called solar pumped lasers, which are new, that do exactly that. They convert sunlight into laser beams. So that's simple enough. But so in order for this to really work is, and I got the idea from, there's an experiment where they're in a vacuum, like a glass vacuum orb. So there's no air or anything, frictionless.
Oh, wow.
And what they do is they have this really light thing with solar sails, they're called, which in space, solar sails are propelled by light. And using just sunlight itself, they accelerate very slowly, but their maximum speed has the potential to be 10% the speed of light.
Oh, nice.
So I saw this video of an experiment where they had this little rotating thing with the solar sails, and they shined a laser beam on it, and it started to move. So, I got the idea to put within a vacuum some magnetic bearings. So there's no, like the average like ball bearings, there's a lot of friction in there. No matter how smooth they are, there's still friction. So frictionless magnetic bearings, and in between them a shaft with the solar sails, and this is all in a vacuum. And what you do is you can get, maybe 4 solar collectors that make 4 laser beams, and they go into the vacuum and they spin the shaft with the solar sails. And then
I see. Okay.
protruding out the top of the top magnetic bearing is another ring of magnets that are arranged positive, negative, which is what you need in a coil to generate electricity. So what you do is, because I can't imagine that there would be much torque, so what you would have to do is you'd have to spin up this magnet using the lasers, and then drop a coil around the alternating magnet, and that would collect all of the energy of the motion, which is potentially 10% the speed of light, which is really fast.
Holy shit.
So if you have 2 of these mechanisms, one spinning up, and then while it's collecting energy, the other one's spinning up, and then the coils, go up and down, and that way there's like a constant flow of a lot of electricity. Now, granted, this will only work when the sun is out, but that's okay, because you can store that excess energy in either batteries or whatever.
Right. Wow, I'm trying to wrap my mind around this. So how does something like that produce, like, what's the end result of that? Like, what does that produce?
In theory, this is all theoretical. I have it all written down on paper. It would cost money to actually develop a prototype. But in theory, it would generate a lot of electricity for relatively cheap. I mean, giant wind turbines are really expensive. They're really gigantic. They take up, a lot of space.
Yeah.
And theoretically, something like the solar turbine would cost a fraction of that and generate at the very least just as much electricity.
Oh, I see.
So it's, it lowers the cost. It could potentially generate more energy, but the experiments need to be done.
Right.
I haven't been able to develop it. I have all kinds of notebooks filled with all of this stuff, and it's all theoretical. I haven't done any math or anything. I've done very little math.
So if any rich scientists are out there or engineers want to help us produce this,
yeah, or at least tell me I'm an idiot, or
some kind of feedback.
Yeah, some kind of feedback. If somebody knows more about this than me, then either tell me, hey, that's a great idea and that could work, or you're an idiot and that won't work. And if you tell me I'm an idiot and it won't work, I'm just gonna try it anyway.
Right, you should.
I'm one of those people that I need for it to not work in front of me.
Well, with all the things I've seen you work on, from making guitar pedals and touch bots and all that stuff, just like crazy electronic things, you always have an intuition for it. So I feel like if this is an idea that you have, it's not, you're not pulling it out of your ass. It's something that has been thought out.
I literally could not stop thinking about this for months.
Wow.
When I got the idea. And originally, the idea was to use superconductors, supercooled superconductors. Because you've seen those videos where you get the superconductor, it's super cooled, and it's on a magnetic track, and it's floating frictionless.
Yeah.
And everyone's like, oh yeah, that's really cool. And I'm like, all right, well, let's do something with this. So I've got designs. Right. Originally, the design is to use that as the frictionless bearing. But I realized that you have to keep the superconductor super cooled, really cold.
Okay.
And, generally in order to do that, you need liquid nitrogen, which, is, it takes a lot of resources to create liquid nitrogen, and it doesn't last forever. You would have to constantly be refilling so the main idea is to have something that doesn't need any renewing. So that's when I came up, I started designing something based off of the super trains, the maglev trains. And with a maglev, you use electromagnets that are constantly shifting polarity to propel the train. So the idea is to not, so it's basic, it's a circular track is the bearing, but it's not nothing's propelling anything. It's just there to make it float. And you have to have one on the top and one on the bottom, and when you build it, you're gonna have to compress it to and it's gonna have to be it's a very specific design, and it has to be done in a way that it won't just pop out, because you're using repelling magnets to create this levitation.
Right.
So you have to kind of sandwich it together and lock it into place. But once it's in place, it should spin freely. And when it's in a vacuum, there's no air resistance. Really, the only quote-unquote friction or resistance would be part of the magnetic fields themselves.
Okay.
But I don't know too much about that.
Yeah. So how does this all connect to the quantum flywheel?
So the quantum flywheel was actually, and it's called that because, as the frictionless motor I was originally designing, it would use the supercooled superconductors. And the theory is, they use big flywheels to store energy, big, huge, heavy metal discs, and I mean tons, really, really big, heavy things. And they use the excess energy from, say, a hydro plant to spin these flywheels up, right? And they spin and they store energy in the motion of it. And when they need to pull that energy out, they connect to a generator, and it spins through a coil, and it sucks the energy back out, and you end up losing energy and eventually like the flywheel will slow down. So the idea with the quantum flywheel was to use the supercooled superconductors, and this would also be in a vacuum. And you would spin this up, and the idea is, the theory is, if you can keep everything cool and within the vacuum, it would theoretically keep spinning forever. It would never lose any energy.
Wow.
And so that's like an idea
awesome.
of storing energy, the quantum flywheel. And it's possible that it could be used, using the magnetic tracks. But there's also this technology where it's being developed, where you can, it pulls the coldness out of space.
Wow.
But it's really actually sending heat into space, because cold doesn't actually exist, just something like less heat. Something that's colder than something just has less heat. So these things basically focus on a frequency that send heat out into space, therefore cooling the object. And it's very primitive, or in its beginning state. But if eventually they could make it so that it's cold enough all the time to keep the superconductors cool,
right?
Then theoretically, boom, there you go. And space itself is cold enough for the superconductors to have that floating property.
Oh, I see. Well, it's a good thing I have you around to explain this stuff, because this is why I'm just a writer. I can't even do math in my head.
Yeah, and if anything, even if I never develop these things, I feel that the ideas should at least be out there, because even if it's not possible right now and I can't do it in my lifetime, say somebody 50, 60 years from now comes across one of my notebooks, and they're like, holy shit.
Yeah, exactly.
Like Nikola Tesla, like he did a lot of stuff while he was alive, but a lot of his designs weren't really developed until after he was gone. And like he's even quoted saying that like, he designed things that just like the technology of the time just didn't allow.
Wasn't ready, yeah.
It was impossible to do then, but the idea was there, and it's possible to do now. So, not comparing myself to Mr. Tesla, but
Well, you're in the same wheelhouse. You're akin. You're as close as I can get to a Tesla. So, be it a car or a human, but. So I love the quantum stuff, and I want to go a little bit deeper. What do you have to say about particles as measurements of waves?
So quantum physics is very hard to wrap your head around, because it's really weird, wonky things happen.
Yeah.
But people, when they talk about particles, like we discovered the Higgs boson, and it's like they didn't really it was always there. They found evidence that it was there, and the thing about it is,
it's a good way of looking at it.
Particles, like people think of particles as like these really small objects, like these unimaginably tiny objects, and because that's the way they present it to the world, because that's the way that the average mind can understand it. But in reality, particles, they're not there. There are no particles. Technically, a particle is just a measurement or a detection of a wave of energy, a frequency.
Wow.
So basically everything on the quantum level is just a bunch of frequencies interacting with each other and creating other frequencies, and it goes up to our level, and our brains are just detecting things and interpreting the world as we interpret it. But the thing about that is, once I came to realize that and try to understand it, because in quantum physics, they're like, well, it's weird because a particle can be in two places at the same time, or they'll say, it'll be here, and then it'll disappear and reappear over here. And, I'm thinking about it, and it's like, okay, well, if you have two detectors, and you're trying to detect a particle, quote unquote, of course, it'll appear that a particle can be in two places at once because you're detecting the same wave in two different parts of space-time.
Wow.
And that means that they're in phase. If you're detecting the same particle in two different places, that means your detectors are in phase of that frequency. And if it seems to disappear and reappear over here, it means your detectors are out of phase. You detected it, and then the wave went away, or the positive part of the wave went negative, and then the other side, your detectors are out of phase.
Okay.
So nothing's actually disappearing and reappearing, or two objects existing in the same place. It's just you're detecting a frequency in two different places in time.
Wow.
Which maybe I'm wrong. That's just the way I understood it.
That seems to make sense. I mean, one of my favorite experiments with delving into that field is the double slit experiment, which is like when I found I discovered when I came upon that, I was just like so mind blown. And it kind of is, it can be almost reality shifting,
So the double slit experiment is something that I have no way of trying to interpret or explain the way I just was talking about what I was just talking about. Because what I was just talking about, that might not be entirely true. That's just the way I interpreted it. Mm-hmm. With the double slit experiment, that's something that is very profound because it shows that the act of observing something changes not only the outcome but like its properties.
Right. Sort of reminds me of the movie Inception, when Leonardo DiCaprio is explaining about how when you get into the middle of the consciousness part of the dream, where you can kind of like harness more awareness or more mobility. It's something, because like I get into the more spiritual aspect of where science takes me, and that's finding some there's some sort of mystical aspect to the quantum stuff.
Right. Yeah. It's like I said, it's some weird freaky stuff happens.
Yeah.
And so to touch base on the double slit experiment, so assuming that everything is actually a wave of energy, and all those waves are interacting with each other, the only thing that I can try to make sense of that is, so it proves that the act of observing this experiment, and therefore probably anything, changes its outcome or changes its properties of existence. So if everything is a wave of energy and those things interacting with each other affect each other on many different levels, it's plausible that by observing it, you're implementing a new frequency,
oh, no shit.
and therefore changing the compilation of frequencies in that moment and space. It's possible. Nobody knows. There are people that have been studying this their entire lives.
Right,
I'm not a quantum physicist.
And it's always changing people's...
I'm just constantly thinking about things.
Right,
and
right.
My brain is part of the universe.
Right.
So...
Well, we've talked before about thought experiments, which is, I think, something that you participate in to, which it's sort of like a creative act, really.
Yeah. Well, Einstein, a lot of the stuff that he came up with started with thought experiments.
Yeah, absolutely. Yeah.
Just thinking about a scenario, but the thing with him was he was able to come up with a theory and prove it,
right.
Or at least even up until recently, his theories have been proven through
they're always trying to test them.
Experiments. but most of them are right. And it's just thought experiments are just, they're fun to do, especially like ones that, break the known laws of physics. Like one of my favorite thought experiments to do is to imagine being able to move faster than light away from the Earth. And while you're moving faster than light away from the Earth, and you look back at the Earth, because you're moving away from the Earth faster than the photons coming off of the Earth, you're basically moving into the past as far as light goes. And
Wow.
so, if you're moving like 10 times faster than the speed of light and you look back at Earth, you would theoretically see it moving backwards.
Right. No way. Yeah.
Because you're going farther and farther away, and you're seeing older and older photons. And then the other thing is, would you even be able to see those photons because you're moving away from them faster than they are? But that's why it's a thought experiment. And then the other part of it is, if you're moving faster than light towards something else, because, when you see a nebula through a telescope, if it's 100,000 light years away, what you're seeing is what it looked like 100,000 years ago.
Right.
So if you're moving towards it way faster than the speed of light, you would see it change, and once you got there, it would be what it is now.
Which we might not even really have a concept of, because
right. It's that's another interesting thing, but in theory you would see it moving and fast forward until it got to the state it is in now. And then if you just leaving Earth faster than light, if you went back to Earth, you would then see that nebula go backwards and back into what you originally saw it when you observed it from Earth.
The fact that the concept of time that excuse me, that people don't even always, I feel like it's such a nonchalant thing how we look at life through the concept of science and time like that, because I did a video recently about how the sunlight that we receive on Earth is 8 minutes old. So it's just crazy to think that whatever activity is happening around the sun, we're not realizing it until after the fact. It's almost like we, by living in time like this, which is why I guess we adapted clocks and things like that to live by, to help keep track of time. I hate when people say, time's not real, and it's well, time is real. We experience it linear, right?
Though maybe that's probably not how the theory is everything's happening all at once, the past, the future, right now, everything is happening in a split second. We just experience it in a linear fashion. And so whether or not time is real is not the question. It's how exactly does it work? And when it comes to that, we invented time. No, we invented clocks to keep track of time. They're a tool of measurement. We didn't, just because we made clocks doesn't mean we invented time. To say time's not real is to say that your car doesn't rust.
Well, it's easy for people to just negate something and play ignorantly.
Sometimes people think they're being they think they're being smart. Everybody's stupid. And it's okay.
Well, with this stuff, it always brings me to my final question, which, to track back to the infamous Albert Einstein, one of my favorite quotes of his is he said something to the effect of, the more I investigate the spiritual, the more I investigate the scientific, the more I investigate the scientific, the more, he had the more understanding of spiritual I become, or the more in awe of it, or something like that. I think that's, being the friends that we are, we've kind of come from two different perspectives. I don't want to say you're a cold, rational mind, not a straight Vulcan, but you are able to process things and kind of, what's the right word I'm looking for?
Analyze.
Yeah, to analyze, and it takes a certain type of mind to have that ability, because a lot of times people can't step out of their own mind, their own mental, BS. And as you say, I've always come from the more spiritual perspective. How do you see the science and spiritual worlds, the way they are connected, like with the quantum stuff and things like that?
I think there's a profoundly deep connection between those things, because they're, on both sides, very strong beliefs, and there are things that we can't explain, that we'll never understand on either side. And I think with Einstein, I think the more he learned, the more he had a hard time believing that it wasn't created. You know what I mean? Everything's so complex and perfect.
Right.
Everything has to be exact for everything to exist, and I think he had a hard time believing that there wasn't some kind of creator, which is
well, what's that old phrase, there's always a clockmaker to the clock or something, something to that effect, where
right.
It's like if you look at, if you use math and science to observe the world around us, everything's broken down that way. The way we understand things like the speed limit or something simple like that, or like a measuring cup, it's like we have these units of measurement, and we design these things to kind of aid us through life, to make things easier. Without that stuff, if you didn't know what number to put your tire pressure at or something, it's
right.
like,
yeah. And there's different aspects of math. I mean, math is pretty much a universal language. I mean,
right.
You can prove that 1 + 1 is 2 by putting 2 apples on a table.
Right.
1 apple plus 1 more apple, there's 2 apples, and
right.
it gets more complex than that. But as far as units of measurement goes, that's always been fascinating to me, because somebody just came up with a kilogram. They were like, this is a kilogram.
Right.
And then it's just
okay,
real, sure. They're like, this is 1 inch, this is 1 yard, this is, okay, well, okay, but what is that, because
yeah, exactly.
There's also the thing where say you've got an object and a wall, and you cut the space between them in half. Okay, it's that much closer, but you can always cut that unit of space in half and never actually touch the wall. You can just keep cutting the space in half. And you'll never touch the wall, which is insane to think about, that there are units of measurement that are that small, and that no matter how many times you cut that space in half, those two things will never touch.
Right.
Wow. So things can, the universe is insane, because it's infinitely huge, and at the same time infinitely tiny, as far as things in the universe go.
Right.
No matter how big something is, there can always be something bigger. No matter how small something is, there can always be something smaller.
Yeah.
Infinitely. Which is just fucking insane.
As our time goes on, scientists and everyone keep discovering more and more deeper layers of everything.
Yeah.
It just keeps going, which is an incredible thing, as life shall keep going on. Well, I'm glad we could touch base on some poignant ideas. We'll definitely return. I'll have you back on the podcast. This isn't a super lengthy science show, so we've only got we only had about 30 minutes in the tank, but
which is
I think
good enough.
I think the knowledge you dropped and the ideas that you expressed are definitely something to ruminate on, and we'll come back to it. And I don't know, do you have any final thoughts, some advice you'd like to give to the listeners?
Advice,
or anything, something from your own mind, something original.
Something original? Oh, I don't know.
Or it doesn't really have to be original. Just something.
Just keep using your mind. Just like I said, the universe is infinite, and you're part of that. Your brain is part of that. So your brain is kind of infinite. And that's why I like thought experiments. You can think about anything you want. Just think about the right stuff.
Yeah.
Think about how to fix things and shit like that.
Possess the right thinking, as
Yeah, there you go.
as they
Possess the
say
right
in my
thinking.
spiritual world. Or actually, I think that was Splinter from Ninja Turtles. But either way, it's still good wisdom.
Very good wisdom.
All right, Brain Mountain, it was amazing to have you on here.
Thank you so much.
My head is spinning, and it's going to take like forever to listen to this, like 10 times. So to figure it out. But you will be back. You will return. I'll figure out how to speak at that point, and we're going to have some good times again. Thank you for listening, everybody, and tuning into the Mythyw Myth podcast. This is Mythyw Myth, signing off.